Hello everyone, I am Saad Zini from the University of Luxembourg. Today I will be presenting our paper titled Using Domain-Specific Corpora for Improved Handling of Ambiguity in Requirements. First, I will introduce the problem. Ambiguity is a property of text and the interpretations held by the readers of that text. The following requirement has a coordination ambiguity in it. It is unclear what the modifier categorized modifies. Does it modify instructions only or both instructions and documentation? When at least one reader acknowledges the ambiguity in the text, we consider this type as acknowledged ambiguity. This phrase has a prepositional phrase attachment ambiguity in it. It is unclear whether the prepositional phrase with tags is attached to the preceding verb categorize, meaning that we use the tags to categorize a set of images, or to the preceding noun images, meaning that we should categorize the images that have tags. In this case, the readers unconsciously disagree on the interpretation of the phrase without being aware of the ambiguity. We will refer to this type as unacknowledged ambiguity. Unacknowledged ambiguity is dangerous because it can be overlooked during a manual review. Ambiguity is an inherent problem in natural language, and in natural language requirements, ambiguity occurs when requirements have multiple interpretations, and this can lead to potential inconsistencies and misunderstandings. And since requirements use domain-specific vocabulary, interpreting requirements requires domain knowledge. Coordination ambiguity and prepositional phrase attachment ambiguity are prevalent in requirements and occur around once in every 4 sentences in our case study. While CA has been explored in the last decades, PAA remains underexplored in RE. Existing work on CA and PAA focus on either detection or interpretation without integrating domain knowledge. Also, the use of domain-specific corpora in RE is very limited. And despite knowing the consequences of unacknowledged ambiguity, it has never been investigated empirically. In our approach, we address these limitations. We do the following contributions in our work. In addition to ambiguity detection, we provide recommendations about text interpretations. We propose a domain-specific corpus generation method that is standalone and does not require any manual annotation or labeled data. Integrating domain knowledge in our approach leads to a significant improvement in the accuracy of ambiguity detection and text interpretation. Our approach detects about 90% of the unacknowledged ambiguity cases. Next, we will present our approach. Our approach takes as input a requirements document written in natural language. We use this document to generate a domain-specific corpus by crawling Wikipedia. We also pre-process the document and extract the requirements that contain coordination and prepositional phrase attachment phrases. Next, we match these phrases against a list of predefined structural patterns, and in parallel, we apply several heuristics. Finally, we combine the results of the patterns and heuristics to classify the phrases into ambiguous and unambiguous. We will go over the steps in the next slides. We generated the domain-specific corpus from the input requirements document. First, we automatically extract the keywords from the document using an existing tool. Say we get the keyword satellite navigation system from this example requirement. We use this keyword to query Wikipedia looking for a matching article. The matching article is an article in Wikipedia whose title has an overlap with the keyword. If we find a matching article, then we add it to our corpus. Then we also add all articles in the same category, the subcategories, and the neighboring categories. The set of the collected articles from Wikipedia is our domain-specific corpus. In this step, we compare the part-of-speech tags of the phrases against a predefined list of structural patterns. We use 27 patterns for CA and PAA, which are reported in the existing literature to indicate likely ambiguous phrases. We also proposed 12 additional enhanced patterns by analyzing a subset of the ambiguous requirements in our dataset. We experiment with both collected and enhanced patterns. Here, the first example, LEO satellites and terminals, matches a pattern in our list, while in the second example, categorize outages with standard discrete tags, does not match any pattern in our patterns list. In parallel to pattern matching, we attempt to interpret the phrases by applying a total of 10 heuristics. We collected and optimized 8 heuristics from the literature and proposed 2 additional syntax-based heuristics. We used the optimized heuristics in our experiments later. 4 corpus-based heuristics require frequency computations from our domain-specific corpus. The heuristics output is a possible interpretation for each phrase. The results of all heuristics can then be combined using, for example, majority vote. In this slide, we show 2 examples of corpus-based heuristics. For CA, we check how frequent the modifier occurs with the first conjuncts. The modifier project modifies only manager in the first example, whereas technical modifies both conjuncts in the second example. For PAA, we check how frequent the preposition occurs with the preceding verb versus with the preceding noun. As we see in the examples, the preposition with is attached to the verb provide, while the preposition of is attached to the noun resilience. The final decision of our approach is based on the results of pattern matching and application of heuristics. In ambiguity handling step, a phrase is considered as ambiguous if either it matches any of the patterns or cannot be interpreted by the heuristics. And unambiguous phrases is the one that does not match any pattern and can be interpreted by the heuristics. Next, I'm going to discuss the research questions and the results of our empirical study. We evaluate our work on a dataset of 20 requirements documents from 7 diverse domains. Out of 5,000 requirements in our dataset, 25% contain coordination or PP attachment phrases. Our dataset was annotated by 2 external annotators, and in total of approximately 3,000 annotated phrases, 62% of ambiguous ones have unacknowledged ambiguity. In the first research question, we experimented with different configurations of our approach, including collected and enhanced patterns. We highlight in blue the best configuration. Our domain-specific approach achieves on average 80% precision and 89% recall for both ambiguity types. Compared to a baseline that uses generic corpus, our approach yields a significant improvement of 28% more precision and 27% more recall. In the second research question, we evaluate the effectiveness of our approach in detecting unacknowledged ambiguity. For this evaluation, we compare the ambiguous phrases found by our approach against the phrases where the annotators disagreed on the interpretation. On average, our approach can detect about 90% of the phrases that have unacknowledged ambiguity. In conclusion, we introduce the coordination ambiguity and the prepositional phrase attachment ambiguity. And we define the unacknowledged ambiguity, which can be easily overlooked during a manual review. We presented our approach for improved handling of ambiguity using domain-specific corpora. We explained our domain-specific corpus generation method, which is standalone, unsupervised, and fully automated. Finally, we showed that our approach provides a significant improvement over the state of the art. This is the end of my presentation. Thank you for your attention, and I am ready to take your questions.
Hello, welcome back to the live session. I hope you enjoyed Saad's really good video presentation. I was looking at it earlier. And I'm happy to have 2 of the authors live here with me and at least one other one hanging out in the chat. So we're very curious to take your questions. And if you don't have any, I certainly do. So let's see. How reliable is the domain corpora mined from Wikipedia? Asks Sridhar. What are your thoughts on that?
Yeah. The reliability of the domain corpora that we mined from Wikipedia can be measured with some similarity measure. For example, between the requirements documents from a certain domain with the domain mined from Wikipedia. And actually, we did some experiments with this using Jacquard similarity and cosine similarity, both measures, and it shows that there is a difference between like a random domain and a domain mined from Wikipedia. That's the one that is mined from Wikipedia is more than 75% similar to the input requirements domain, rather comparing to another random corpus from a generic domain.
Okay, thank you very much. Let's see. Bashar is asking, what is the role of the reader in your work? The dataset is not necessarily the only facet of the domain specificity, one of my favorite words. I stumble over it every time. The variability of readers may also matter. Also, some ambiguities are more serious than others, maybe. So first piece, domain specificity. What about the role of the reader in your work?
Yeah, the reader represents the analyst or the software engineer that deals with the requirements. And in our case, we have two annotators, which are the readers. Their role is to reflect the different interpretations that can be faced in the analysis stage, where these ambiguities can be critical, and what was the second part of the question?
The second part was that some ambiguities are more serious than others.
Yes, that is true. There are several types of ambiguities, and for syntactic ambiguities, we refer to Danbury's handbook about ambiguities in requirements. And the two requirements types that we worked on are the first and second most common requirement ambiguity types in requirements, syntactic ambiguity types in requirements. And maybe there are other requirements that are other ambiguity types that are also important in requirements, but these two that we choose to work on are the most common ones.
Okay, great, good. So that's some pretty good.
If I may add just one extra statement about the first part of Bashar's question. This is indeed a very valid question. So the background and expertise of the people who read the requirements have an important role to play here. What we considered in this particular paper was the domain specificity of the corpora, but we indeed have to investigate how this is going to play out with different types of readers. So what we had were generic rather readers who were not specifically experts in the domains that they were reading the requirements of. This is something that we'll have to look further into.
Okay. You get a thumbs up by Bashar. It's flying through my screen. Wow. Martin Glintz also has a question for you. Did you take into account any project-specific glossaries which contain a lot of domain-specific information that can be used for disambiguation?
I guess the question is, did we use any of the glossaries that were available in some of these documents?
Yes.
Or did we just put them aside?
No, where the document requirements document that we have in our dataset, we extracted the glossary terms using an RE tool for glossary terms to what?
No, go ahead.
Yeah. So we extract glossary terms from the input requirements documents to to use them to query Wikipedia. They are like as the main keywords that we use to query Wikipedia. I guess.
Could you comment on any of these documents having glossaries beforehand? Because the ones that
no, we don't have glossaries for it.
Okay. That was the
Otherwise
problem.
we could have used them.
The vast majority, if not all of these documents, came without glossaries, so there was very little to go on. We had to come up with the glossaries based on an automated tool that we already had.
So would you say that the main impact of your research is that you're going to rescue all those requirements engineering specifications that are doomed to fail because they were too lazy to make a glossary, and now you're going to do it for them by retrieving them automatically from Wikipedia?
The glossary extraction method that we use is not this role is not to replace the glossaries that are missing, but to help us like
too lazy.
Yeah.
Sorry, please go ahead. Finish your point.
To help us identify the exact domain of the document using these glossary terms that we extract. And this is the main objective.
Okay. Would you say that may be a second use, though? Could we use the corpus that you pulled to create a glossary? Would that be of any help?
I can take this question. I think absolutely yes. In fact, one of the things that we are looking at is if we were to identify such a glossary, how is it going to fare against the terminology that you already have in your document? And if there is a discrepancy, you could use that for determining areas of incompleteness. So absolutely, this is something that we can look into. Yeah.
There we go. We designed your next study. You're welcome.
Yes.
For a coffee with
thank you so much. Well, yeah, we've discussed this before internally, yes, but this is a very, very valid idea. Very smart.
Okay.
Question. Thank you.
That's what happens with so many great research ideas. We're not the first ones to have them. Okay. But so as there is no other question in the chat as of now, is there any exciting updates that you can tell us what happened in the last 8 months since you submitted this paper? Any new insights in ambiguity?
Yes, recently we have been exploring other types of ambiguity and requirements, and also exploring other methods like using machine learning and like updated techniques.
Okay.
And if